Okay, our second lesson in this chapter is on congruent triangles, which we will be working a lot with throughout the whole entire school year. We have several targets here. The first one says I can identify included angles and included sides. Those are kind of key vocabulary terms that we're going to be using. And then you see we have three separate postulates that we will talk more specifically about in a minute. So let's review. We had this definition of congruent figures earlier in the chapter here in section 3.1, and we said if all pairs of corresponding sides and angles are congruent, then the figures are congruent. So what we know up to this point was that if I was trying to get triangle ABC congruent to triangle DEF, I would have to have all pairs of corresponding sides. So I would have to have AB congruent to DE, AC congruent to DF, and BC congruent to EF. And angles. So I'd have to have angle A congruent to angle D. I'd have to have angle B congruent to angle E, and I'd have to have angle C congruent to angle F. That's a lot of work just to say that those two triangles are congruent. That is three pairs of sides and three pairs of angles. So today what we're going to look at is, are there some quicker ways that we can use to guarantee that the two triangles are actually congruent without having to get all three pairs of sides and all three pairs of angles? That's where we're headed. Okay, so first we're going to talk about an included side. An included side is the side that is bounded by two angles. So in triangle ABC, I could say BC is included, right? This side right here is included between which two angles? Angle B and angle C. That is an example of an included side, a side that is between two angles. So if I wanted to talk about side AB is included between angle A and angle B. So same idea, included angle is the angle that is bordered by two sides. The angle that is bordered or bounded, however you want to say it, I'll use both words here. So in the example above, I could say angle B is bordered. Now look up above at angle B. Angle B is bordered by what two sides? By side AB and by side BC. Okay, so angle B is the included angle between these two sides, and side BC is the included side between angle B and angle C. All right, so if you look below here, we're going to do a little bit of an investigation. Whoops, that's a little too far there. All right, so it says if we take the converse of our definition of congruence, we have if all corresponding parts of two triangles are congruent, then the triangles are congruent. So that's what we were talking about a minute ago. In order to say triangles are congruent, right now we have to have three pairs of sides and three pairs of angles, which is just a lot. So we're going to see if we can narrow that down. So if you look at number 1, if I can keep it on the screen here, it says choose three lengths and construct a triangle. Can you choose the same three lengths and make a different triangle? So let's try here. Here's one length. Here's another length. And let's see if I can make a triangle out of them. Something like that, right? And if I take the same three lengths, can I make a triangle that's different? So if I use the same three lengths, if you look closely, I know these aren't exact. I'm going to scoot it up so you can see it better. If you look closely, these two triangles are the same size triangle. No matter how I try to rearrange these three sides, if I go up here and I put the red one there and the yellow one here, no matter how I do it, they're really going to be congruent triangles. I cannot rearrange the three sides in any way, shape, or form to make a different shaped triangle. It might be a reflection of it, a rotation of it, a translation of it, but it's going to be the same triangle. So on our sheet here, when it says choose three lengths and construct a triangle, can you choose the same three lengths and make a different triangle? The answer is no. Okay? Three lengths determine a particular triangle. That's going to be one of our postulates. The next one says to try out two lengths and a given angle. Okay? It says, can you choose the same two lengths and a given angle and make a different triangle? So now let's try that one. Let me get some angles out here. All right, so if I stick with the purple and the yellow, and I use this green as my angle measure, all right, let's make a triangle. If I put that side there, and this side right there, okay, I need a side to close it off. So we might have a triangle that looks like this, all right? There's one possible triangle, but now if I use the same angle again, let's say I put the purple down and I put the angle on the same spot, but now what if, I'm off the screen here, sorry, what if I put the yellow side over here? Would that make the same triangle? I have to find a length now that's going to connect this side with this one. Well, I think you can see just by the segment I pulled out there that all of a sudden it makes a pretty different triangle. So notice both triangles have the green angle. That's the same angle measure. They both have the yellow length and they both have the purple, but I have two very different looking triangles. So unlike what we had in number one, where no matter what way we rearranged the three lengths, it made the same triangle. Here, if I have two lengths and an angle, it does appear that I can make different triangles. So it says, can you choose the same two lengths and a given angle and make a different triangle? Yes. So right now, two lengths and an angle do not guarantee me congruence, unlike the three lengths did. But look at what 3 has us do. It says repeat this, but make sure the angle is between or included, right, the sides. So let's go back to our picture, right? If you look at my 2, all right, let's take these away to start. This angle was included between the yellow and the purple. So now let's say we have to keep that as a rule, that the angle has to be between, and let's see if I can try to rearrange it to look a little differently. I'll put the purple on top here. I'll leave the angle, but the angle has to be between the yellow and the purple. All right, could I get different triangles like that? Well, this one is still going to make that triangle. And if I close off the remaining side on this one, if I connect this point here to that point, I hope you can see those look like the exact same triangle. So in fact, if you keep the angle, the specific angle measure between the same two sides, you will guarantee that you have to produce the same triangle. Again, it might be a reflection, a rotation, a translation, but it's going to be the same size triangle. So the answer to question 3, make sure the angle is between the other sides included, that answer would be no. We would get the same triangle, right? Which is kind of what we're looking for, because that preserves congruence. The same triangle means we are preserving congruence. All right. Last one says choose one length and 2 given angles. Making sure the side is included, how many different triangles can you get? So let's see if I can leave that up here. So this time we have to have 2 angle measures. So let's dig those out first. So here's one angle measure, and here's another angle measure, and I need an included side. So I'll go with the red. And let's say I put this red side between these two angle measures, right? What kind of a triangle can I get? Well, I think I have the right length sides here. Well, my segments aren't working too well here. And we need another side here. All right, so using the two angles on the red side, it looks like I could make that triangle. Now remember the rule, I have to keep the side, the given side, the red one, between, right, included between the two angles. So if I just mix up the angles, which seems to be, I think, my only option that way, and I stick with the red side, let's see if I get a different triangle. All right. I think you're going to see if I connect these here. Should look like the same triangle. It's flipped around, right? The blue side landed over here, but if we were to look at, is this triangle congruent to this one, I think your answer would be yes. So in choosing one length and two given angles, that was the red, and the two green angles, making sure the side is included, how many different triangles can you make? Well, we can only make one triangle. So I'm going to say just one triangle, which means it does in fact preserve congruence. So what we're trying to get at are these three postulates that we talked about here in the targets that I glossed over. SSS has to do with this first one that we talked about right here. If you have three sides, you can only make one triangle. So side, side, side is going to be a way to prove triangle congruence. In part 3, we determined that if the angle was between the two lengths, see it said make sure the angle is between the two sides, it was included, that indeed we preserved congruence. That's going to be side, angle, side. You see that in the targets. See how the angle listed is in between the two sides? We'll talk about what these mean more in a minute. And then this last one, we showed that if we had two angles and a side, and that the side was included, again, we could only get one triangle. So that's our final postulate called angle, side, angle. See the side between the two angles. So let's turn the page and actually write these out. So we're going to say if all sides of one triangle are congruent to all sides of another triangle, then the triangles are congruent. We call that side, side, side. So basically, if these two sides match, if these two match, and if these two match, we could definitely say those triangles are congruent. Then we had, our second one was if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. That was the one we called side, angle, side. Here's what that means. If I draw two triangles, in order to prove they were congruent, I'd have to have two pairs of sides, and then note this is really important here, the included angle. So not just any angle, but the angle that's included between those two congruent sides. That one is what we call side, angle, side. The last one, sort of the reverse of that, it says if two angles and the included side of one triangle are congruent to two angles, and the included side of another triangle, then the triangles are congruent. So that's the one we called angle side angle. So to keep the picture simple, this time I have to have two angles. So let's mark two pairs of angles congruent, right? And it has to be the included side that we have. So that would have to be this side right here. That's the one that's included between the angles. So we can now narrow down. We don't have to have all three pairs of sides and all three pairs of angles. We can either have just the three pairs of sides, two pairs of sides and the included angle, or two pairs of angles and the included sides. That is enough to get triangles to be congruent. All right, so let's just look at some simple examples here. It says in example 1, which postulate proves the triangles congruent? So why are these two triangles congruent? And I am missing some marks on these. I apologize. I believe you have these marked. So on this first diagram, it appears that we just have two pairs of angles marked. So I'm leaning towards this, but where is this included side? Well, hopefully you realize that this side right here belongs to both triangles. So it's congruent to itself, we could say by reflexive. And so then I would have an angle, and an included side. An angle, and an included side. So that's going to be angle side angle. All right. In this one, I believe I'm missing these markings. All right, so why is triangle ABE, this one on the left, congruent to CDE on the right? Well, again, it only appears that I have two parts. I have this side matching this side, and then these two sides matching. So it appears that it would either be side, 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 or it would be side, angle, side, because those are the ones that have the two sides. But I'm missing something, so hopefully you look in the middle and you realize you have vertical angles. As soon as I mark that, I realize I have the two sides and the included angle. A side, and the included angle on this triangle, and a side, and an included angle on this triangle. So that's side, angle, side. All right, the marks I'm missing here are these two, and then I have this one congruent to this one. So those triangles are kind of sitting on top of each other. If you look, it's triangle ABD and triangle CBD. Again, if you're looking above, I have two pairs of sides, so I'm leaning towards one of these. Well, which one is it? Hopefully you realize they both share side BD. I could put a congruent mark on and think about that as reflexive. And then I would have side, side would make those two triangles congruent. All right, so down here, let me fill in my missing markings. The question says, what missing congruence do you need to prove the triangle's congruent? So let's mark the triangles we want congruent, first of all, because we've got a lot going on in this diagram. We want triangle ABE congruent to triangle CDF. I want those two triangles congruent, right? So let's see what I have so far. I have a side, and I have an angle and an angle. So if I want to use side, angle, side, it appears that I'm missing this last side, right? I have a side and an angle, a side and an angle. Remember, that angle has to be included between the two sides. So if I just look at this triangle right here, all right, let's cover up the one. I've got a side, I've got an angle. Think about which side would include that angle. Well, the angle is right here. I have the left side, so I must need this right side, but it's for the whole triangle, so it's going to be this side right here is the piece I would need. I would need BE, and then which side would I need on this triangle right here? I have this side and this angle, so the included side would be this piece right here, which is DF. That would give me side, angle, side. Now, if I think about it in terms of angle, side, angle, right? If we come back to this first triangle right here, this one, if I have angle, side, angle, I have an angle and a side. I need another angle. Well, don't forget the side has to be included. So I think I have to pick this angle right up here because then I'd have two angles and the included side. So that would have to be this angle, which I would call BAE because I'm missing this one. All right, and then on this triangle, I have an angle and a side, so this would have to be the other angle that would include this side. So that would be angle DCF. And that's how I could get them congruent by angle, side, angle. All right, on this one, I have these angles marked and these sides marked, and the first thing they want is side, angle, side. Well, I have a side and an angle, so I'm missing the side. Don't forget, this missing side must include the angle. So look at the top triangle. Which side, either CB or AB, would include this angle? Hopefully you can see it's this side right here, because then I'd have these two sides include that angle. And then down here, I need the side that includes the angle. So I have a side and an angle. I'd have to have this side that includes the angle. So this missing side would have to be AB and E. This is supposed to be a D there. AB congruent to ED. Now if I want to get angle, side, angle, I'm clearly missing the other angle. So back up to the top triangle, angle, side, I have to have the angle that includes the side. That would have to be this one right here, because these two angles would include this side. So that's angle ACB. And then on the bottom triangle, I have an angle and a side. So which one will include this side? Angle, side, it would have to be this angle. The side would be between the two angles. So that angle is ECD. Okay? All right. Let's actually try it in some proofs. So we have angle 1 congruent to angle 2, angle 3 congruent to angle 4, AC bisects angle BAD, and AB is congruent to AD. That is a lot of given. Let's mark it up. 1 congruent to 2, 3 congruent to 4, AC, let's use color to highlight this, ray AC bisects angle BAD, so that orange is a bisector, and then I have segment AB congruent to segment AD. And I'm trying to get triangle ABC, this whole guy on the left, congruent to this whole guy on the right. So maybe I'll mark those. I'm trying to get these green triangles congruent. Well, I don't think I have any of the parts so far. When I look at the green triangle, oh, actually I do. I lied. I have this top segment congruent to this top segment. So I do actually have a side, right? You should look closely here and here, right? You have congruent angles next to each other. I hope you realize that's addition, and I can add these two and add these two to get angle ABC congruent to angle ADC. And that would be if congruent angles are added to congruent angles, then the sums are congruent. So now I have this whole angle, darken it in there, is congruent to this whole angle, and that's an angle in this green triangle, and this is an angle in this green triangle. So I now believe I also have an angle. So now I know I'm headed towards either side, angle, side, or perhaps angle, side, angle. So I need something else. I look at the given and I realize I have not used this orange bisector. Right? If a ray bisects an angle, it divides it into two congruent angles, which would be those two at the top. So I know angle BAC would be congruent to angle DAC by if a ray bisects an angle, then it divides it into two congruent angles. But now look again at this green triangle. Let's just look at the one on the left. All right. I have this angle, I have this side, and now don't I have this angle? And if you look closely, you'll see my side is included between these two angles. So I believe I can say the triangles are congruent by angle, side, angle. Looking at the right triangle, I have an angle, a side, and an angle, and this side is included between those two angles. All right, for AE is congruent to DE. E is the midpoint of BC. Angle AEC is congruent to angle DEB. AEC congruent to DEB. And then what did I say? E was a midpoint. I'll darken that in. That's all given. And I'm trying to get the two triangles congruent. I think the only part of the triangles I have so far is a side. Don't say the angle is, because this big angle right here is not actually in the triangle. It seeps outside the triangle. And this angle right here also seeps outside of this triangle. But if you look closely at those angles, I hope you realize we have overlap. So I think I can subtract that overlap. If I do that, I should get angle AEB congruent to angle DEC by if the same angle is subtracted from congruent angles, then the differences are congruent. That gets me this angle congruent to this angle. These angles, the ones I just marked, actually are in the triangle. So I'm going to list an angle. So again, I'm headed towards side angle side, or perhaps angle side angle. I'm looking at the given and see what I didn't use yet, and I realize I haven't used the midpoint. It's a single midpoint. If E is the midpoint of BC, I should know that BE is congruent to EC. If a point is the midpoint, then it divides it into two congruent segs. Now take a good look. That's another side, and isn't that side including this angle? Here's my angle, and here's my two sides. That's the included angle. Here's my two sides, and here's the included angle. So I think my triangles are congruent by side, angle, side.